Alright everyone, welcome to another tutorial. So today we will be solving a problem involving a second derivative of a function. So one application of that is finding the radius of curvature. So we have this problem. What is the radius of curvature at point 1, 2 of the curve 4x minus y squared is equal to 0. So first what we want to do is to express the function explicitly. So y is equal to square root of 4x, or that is just simply y is equal to 2 square root of x. So in order to solve for the problem, we need to know what is the formula of the radius of curvature. The radius of curvature is just the inverse of curvature. Okay, so which is, the expression will be 1 plus y prime squared raised to 3 halves all over y prime prime, the absolute value of the second derivative of function at that point. So this might be easy to take the derivative, but there are some cases that the function is very complicated to take the derivative, especially if you're taking the second derivative of a function. So first what we want to do is to get our calculator. We press shift this key and you will have this in your display. So we will just plug in the value of this expression to square root of x. So 2 square root of x, and the x will be equal to the value of x at that point, which is 1. So 1. So once you get the value, save it, shift store A. So put it A. So press the up arrow, and then what we will do is add 0.00001 there, and then we will save it again on another letter. So what we will do is we do b minus a all over 0.00001. We will approximately get this is the value of our second derivative at that point. So that would be y prime prime equal to negative 1/2 or negative 0.5. So we know from our value, the value of the first derivative earlier, okay, is 1. Obviously it's 1 there. So we know that the first derivative is 1. We can now plug in the value to solve for the radius of curvature, which is rho 1 plus first derivative will be 1 squared raised to 3 halves all over the absolute value of the second derivative. We will approximately get a value of 5.66. So this will definitely speed up your calculations, especially if the function is very complicated to take the derivative. But in this example, it's just a simple, no? You can just take the derivative without any problem. But the limitation of this is that when you cannot express the function in terms of x, then you cannot use this technique. So this is only applicable for functions, particularly explicit functions. So that's all for today, and please don't forget to subscribe.